Okay, everybody, this will be your first online learning module daily. We left off in the middle of a lab, finish that when we get back, so on to the new stuff. And the new thing that we will be talking about is REDOX. REDOX, often written in all caps, is a type of chemical reaction. Like we've talked about double replacement, single replacement, synthesis, decomposition, combustion, acid, base, neutralization. Redox is a type of chemical reaction where something is reduced and something is oxidized. And those two terms mean reduction is the gain of one or more electrons. Oxidation is the loss of one or more electrons. You can remember this by thinking oil rig. Oxidation is loss. Reduction is gain of electrons. That's basically it. Redox, oxidation, reduction. If something gets reduced, it gains electrons. If something gets oxidized, it loses electrons. Whatever is reduced is the oxidizing agent. Whatever is oxidized is the reducing agent. And that's pretty much it. If you review the notes, it'll walk you through this. I'm going to walk through some examples with you. And I also have an oxidation explained document on Classroom for you to review. So, oxidation reduction chemical reactions are not cut and dry. Like, these are only redox reactions and nothing else. For example, a single replacement reaction such as a silver nitrate plus copper reaction, which if you remember the good old activity series, whatever element that is alone, in this case copper, as long as it is above the similar element in the compound, the reaction will proceed. So for this single replacement reaction, we would actually precipitate out solid silver from our silver nitrate solution, and then we would end up with copper 2 nitrate solution. The balancing is not super duper important to us right now, just because it's prettier that way. We will do that. So when we're talking about redox, you have to go through and assign an oxidation number to every element in your compound. And if you have a lone element, oxidation numbers will be 0. Silver, copper, 0. Silver, 0, because they're lone pure elements all by themselves. Since nitrate as a whole is a -1, and there's 2 of them, that means your copper is a +2. Over here, your silver was a +1. And each oxygen will be a -2. Since there are 3 of them, for a -6 total, and the whole thing is a -1, that means nitrogen is a +5. Since we have nitrate on both sides, we can basically ignore it. So nothing is changing with the nitrate. However, we can see that copper on the reactant side started as a 0, and then it went to a +2. Similarly, silver on the reactant side started as a +1, and it went to a 0. Because whenever you have a pure element all by itself, the oxidation number will be 0. Then you have to think about what is happening. Since we are thinking about things in terms of electrons which are negatively charged, if something goes from a 0 to a +2, that means it lost electrons.
Good afternoon. Students, before we dismiss, I would just like to remind all of you
And that means it was oxidized, which means it was the reducing agent. If something goes from a +1 to a 0, it gained electrons,
you don't need to be going to movies and things like that.
Meaning it was reduced,
Or one, a bag of snacks,
making it the oxidizing
We
agent.
have them on a table in the rotunda, so on your way out today, feel free to take a bag or two with you if you want that food over break. Also, please check your email while you're off. That's how we're going to be able to communicate with you. And we're going to miss you while you're off. Stay healthy, and we will see you soon.
So that is one example of a redox reaction. We'll go through another simple one here together. So if we have the synthesis of strontium oxide, oxidation numbers. Strontium starts out as a 0. Oxygen starts out as a 0 because these are pure elements. Pure elements always have an oxidation number of 0. Over on the product side, we have an ionic compound. Oxygen, we're going to go with it being always a -2. So oxygen went from a 0 to a -2. Strontium, alkaline earth metal, will always be a +2. On these periodic tables, you've seen them before, we've worked with them before when we did nomenclature. They're coming back. You can see oxidation states right there. Those are those little tiny numbers we've been using. Now they have a little bit more meaning. So, hydrogen, pretty much always going to be a +1. It can be a -1. That's a strange circumstance that we will not be working with. So if it is in group 1, always +1. Group 2, always +2. Transition metals, as usual, can't trust them. Like ruthenium, if it has more than one, it depends on what it's bonded with. Something that has more than one option will always be bonded with something that you can trust, meaning you can always assume it to be a particular charge. Oxygen could be a -1. For us, it will always be a -2. So you will be needing to use this as a reference. So that way you can figure out what you can trust and what you cannot. For us, in this example, you can trust both of them because as an alkaline earth metal, strontium will always be a +2, and for us in here, oxygen will always be a -2. So if you go from a 0 to a +2, that means you are getting more positive, meaning you have a loss of electrons. And if you have a loss of electrons, that means it was oxidized, making it the reducing agent. If you go from a 0 to a -2, you are becoming more negative, meaning you gained electrons, making this reduced, making it the oxidizing agent. On to the next section. So that is how you would assign oxidation numbers to elements in reactions and in compounds. So if you have a pure element, it will always be 0. If you need to figure out the oxidation number for an element in a compound, you will have to figure out what you can or cannot trust. So H2SO4. We know that sulfate is a -2 charge polyatomic ion. However, where does that -2 charge come from? Well, hydrogen, for our purposes, always a +1. Sulfur.
Students, you're now dismissed at this time.
Could be a couple of different things. Oxygen, for our purposes, will always be a -2. If there are 4 -2s, that means we have a -8 total for that charge, for all oxygen atoms. If we have 2 hydrogens, it will cancel out 2 of those negative charges, so our single solitary sulfur atom will have a -6 oxidation state charge. What I would recommend you doing, so let's say we are going to do potassium dichromate. I have this on Classroom. Use this box, it will help you out a lot. So if we have the compound K2CR2O7, break it up into the different elements. We have potassium, chromium, oxygen. There are 2 atoms of potassium and chromium, 7 of oxygen. Potassium, looking at the periodic table, alkali metal, always a +1. Chromium, I don't know. It's going to be a positive, but we don't know what it is. Oxygen, always a -2. Total contribution of charge you get by multiplying this number by that number. So 7 -2 equals a -14. X times 2, 2x. 2 plus a +1, +2. Write an equation setting them all to 0 because this compound does not have a charge on it, just like when we did nomenclature. So if we have 2 plus 2x equals, plus a -14 equals 0, we have 2x minus 12 equals 0, plus 12 plus 12, 2x equals 12, x equals +6.